So if we draw the curve, y equals x squared is just your standard parabola, right? So it's gonna look like that. And then the line y equals x. Okay, so yeah, this is not gonna be to scale either, but that's okay. Because yeah, so here between, there we go. So this is gonna be 1, and then this is also gonna be 1. Because the only time that these two functions intersect are when x and y are both equal to either 0 or 1, right? That's the only time. And so we already know our limits of integration, but we are going to flip this around, around the line x equals 2. And so what we're gonna have on this side is something that looks like this. Let's see if I can do this. It's not terrible. So these are the regions that we're looking at. So now, because I've revolved it around a vertical line, my cross sections have to be perpendicular to that, so they're gonna be horizontal. What is this entire distance given by? This orange distance right here. What is that? 2. So then if I want to just find this distance now, what am I subtracting right here? Yeah, but then since we're doing it with respect to y, what am I going to have instead of 2 minus x? Yeah, 2 minus y. So does that make sense? Does everybody see why now r1 is equal to 2 minus y? It's a lot easier if you think about it in terms of the whole thing first, and then think of the distance that you're essentially getting rid of, rather than thinking about it in terms of adding like I was doing in the other examples. All right, so to find the larger radius, right, if you look again, the radius is going to be given by this green piece right here that I just covered the red with. And so it's going to include, in my 2D circle, it's going to include both the colored in pieces and the empty piece, right? So this is going to be R1, this is going to be R1. Here, this is going to be R1. So what I'm going to do is I'm going to kind of copy this down below so that we can just focus on R1. And so then here's the line y equals 2. Here's the x-axis. So it's something like that. Then this distance right here, we already talked about, that's 2, right? So this is 2. So and then what you're looking for, actually let me put this in a different color. So this is 2. And what you're looking for is just the piece that I have up here in green. So just this dark green piece. So essentially you're removing just this tiny little piece right here. And this piece is given by y, right? Because that's the line y equals x. And so in terms of y, it's just y. And so that's why R1 is going to be 2 minus y. So yeah, here, if you look at it on the left of your axis of revolution, it's a lot easier to think about it. And in my previous explanation, I was trying to explain it on the right, and it's just a lot easier to see it on this side. And so yeah, R2 is given by just the radius of that inside piece, right? So just this empty piece right here. So this is R2. I'll erase this one. And so if we think about it in terms of the way we just thought about the other one, this whole distance is given by, we already said it was 2. And then now we're subtracting not just this piece, but also this piece. And so this piece, instead of being given by y equals x, this is now y equals x squared, or in terms of y, x equals the square root of y. So that's why R2 is equal to 2 minus the square root of